So does this box look familiar to you? If the title card and intro haven't given away, snap circuits are back. And yes, it's been a long time. The last time I did a video, believe it or not, was February of 2017, according to the date I have on YouTube, and I think I left off about getting replacement parts. So, to get back into it, what we're going to do here is kind of do troubleshooting in inventory. So, I'm going to open up our set here. The SC750 is what I've got, that's what I've been using. And we're going to go through all the parts to see what we have in case we're missing anything, because again, it's been a while. And two, we're going to do troubleshooting, so we're going to go through and test all the components out one by one to make sure that they're all working before we get into our projects, and this way you can troubleshoot your own sets and parts too, is when you're doing your own. So let's open the box up. Get it out of the way here. And then we start with the lower portion, since the top portion's got all those components in there. So in the 750 set, on our second set, we have our manuals. That's projects 1 through 101, 102 to 305, up here, 306 to 511. And then we have the one for this set, 512 to 692, including our manual for the computer portion. There's our disc, and I've heard that this is an older set that has the CDs. The newer ones, they actually have you download the software from the ELENCO or ELENCO website. I'm realizing there's two different variations on how that's pronounced, and I'm beginning to wonder if I'm really supposed to be saying ELENCO, but we'll see. So, we have our B2 solar panel. This is our little adapter for custom components, which goes right into the springs there. So we have our own resistor, capacitor, inductor, or something like that. We can use that. And there is no inductors in the snap circuit set, so this is a good thing to use an inductor for. This is our little spring switch, so it closes a circuit when it's being shaken. This is our pack of paper clips, which we use with our electromagnet in iron core rod, right there. So that is there. And this is our computer interface cable that makes use of the microphone port. 3.5mm microphone port on a computer with our alligator clips. And then this is some additional documentation, color wheel, stuff like that for some other projects. So that covers the top bin in its inventory. So everything is there for that. Get this part out of the way. And now we're going to look at all the main components here, see if there's anything missing. So we have our grid, which is pretty much fundamental because that's where everything goes. We have our, let's see, this is our high frequency IC, U5. This is our NPN transistor, Q2, PNP transistor, Q1. Here's our variable resistor, or V. Our capacitors, we have our 0.02 microfarad capacitor, a 0.1 microfarad capacitor, 10 microfarad capacitor. We got 100 microfarad capacitor, and this should be our 470 microfarad capacitor. So there's all our capacitors. Let's look at our resistors. Let me take this little stack out. That makes it easier. So we have our 100 ohm resistor, 1000 ohm resistor, Let's see, that's our 5.1K resistor, or 5100 ohms, 10,000 ohms, and then our last one should be the 100,000 ohms at 100K. Okay. And while I'm looking at this, these are our 1 snap connectors. And there should actually be 6 of these, and I've only got 5 of them, so I had lost one of these at one time. So I am probably going to have to request a replacement part because I am missing one. Which, of course, like I say from my previous video I did a while back, you can get free replacement parts as long as you're an individual consumer and not a business or commercial user of snap circuits. So let's continue. This is our, let's see, there's our microphone. There's the photoresistor. This is L2, so this is our 6-volt lamp. L1 is our 2.5-volt lamp. There's our whistle chip. And while we're looking at our snap connectors, let's look at our snaps down here. 2 3 snaps plus 1 7. We have 2 more 3 snaps plus a 6. These are number 5 snaps. If I get this out right. Okay, I got 2 5 snaps. 2 4 snaps. I have to get around the camera here because it's way up in the air. And these are our 2 snaps. So we have 3 there, 3 there, 3 there, and 3 there. So 12 of those. Alright. There's to the side. Here we got our T1, our transformer. Here's our FM receiver module. Get that antenna back down there. Let's see. There's our amplifier integrated circuit. There's our Space War sound IC. Our alarm sound IC. There's our music sound IC. Okay. Let's see, we have our red LED D1 there. Here's our green LED D2. Okay. There's our 8-segment LED display with all its connections. Let's see, there's our silicon controlled rectifier, or SCR. And under that is our ammeter for looking at current ranges. And we got our S3 relay. There's our recording IC used for recording and playing back audio. At the top here, here's our black wire, shorting wire. There's our red short wire. There's our slide switch. There's our push button switch. And that is our diode. So D3, that's our standard diode. Around this side, here's our antenna module, used for AM radio and for other components. There's our variable resistor. There's our motor. There's the fan blade that goes on top of it, plus our speaker. And then we have at the top here our 2 B1 battery banks. We have this one and we have the other one. So that pretty much concludes the inventory of the SC750 set here, of what you should have. And of course the SC100, 300, 500, and 750 all go up to this. It's just how many components those sets have. So the only part that I'm really missing is one of these single snap connectors, but think for now I can make do with only 5 of them. So let me put them back here. Once I realize where they go. So now that we've done the inventory of the SC750 set here, now we're going to go into troubleshooting. So we're going to look at every individual component, make sure that there's no broken connections, that they're functioning the way they're supposed to be, etc., etc. So we're going to go through the manuals and their troubleshooting sections, and we're going to again test each component out one by one. So we're going to do that now. So here we've got the manual for the SC100 set, so that's where we're starting our troubleshooting from. And just a few pages in, we can get right to our troubleshooting section. So we're going to start with the first one here, and that's going to have us looking at our 2 battery boxes, our 2.5 volt lamp, our speaker, and our motor. So we want to make sure that we're getting power through our battery boxes, that the little thermistor or wires in there are not damaged, that we don't have a burned out filament in our 2.5 volt lamp, that the windings are not burned out in our motor, nor are the windings burned out in our speaker. So what we're going to do is we're going to connect those 3 across those batteries, and we're going to check all of those components. So I just put some rechargeables in here, and I guess I'll find out if these rechargeables are still good too. So here's our 2.5 volt lamp. I put that across there, and it lights up. So the batteries are good, the battery box is good, our lamp is good. Repeat it over here with this battery box, and that lights up nice and bright. So this battery is good too. Let's go ahead and check our motor. Place it along the contacts. And our motor spins one direction and spins the other direction when we reverse polarity. So the motor is just fine. And last is our speaker. We should hear some static out of this. And we do. So our speaker is good. So those components test all good so far. So now our next segment is going to be looking at the jumper wires, and we're going to test out the snap wires. So here I've got all the snap wires, and I've got our jumper wires, and what we'll do is we'll use our 2.5 volt lamp as our indicator to tell if they're good, and use one of our single battery boxes. So I'm going to take a 2 snap here, just connect that there so we can test that at the same time. Take this red jumper and hook it to the lamp there, and to there. So our red jumper wire is good. Black one. That one's good. And we'll continue using these. So we know this 2 snap is good. Pull out another 2 snap. And we just leave this connected to that. So that is good. That one's good. That snap is good. That one is good as well. That's good. And it's good. That's good there. That's good. Good. And good. So that's all our 2 snaps. Let's look at our 3 snaps. Test good. That one's good there. Good there. Good there. So our 3 snaps are good. Do the 4 snaps. This one's good. That one's good. So now we're going to move on to our 5s. That's good. That one's good. Let's check our 6. That's good. And then our 7. This is getting a little stretched here. And that one's good. Then I'll check all these single snaps at once. Got the light popping off. And that one's good. So all our snap and jumper wires test just fine. So our next item to test is going to be our 2 switches, our slide switch and our press switch. So let me get those out. So we're testing our slide switch and push button switch now. The manual has us build project 1. I just simplified it by making it a little smaller. So if I turn the slide switch on, our light lights up, so we know that our S1 slide switch is good. Let's look at our S2 push button switch. Push the button, and that lights up. So we know that our slide switch and push button switch are good. So now we're going to look at the 100 ohm resistor and the LED D1 next. So for testing the 100 ohm resistor and our red LED, it has us build project 7. Again, I just simplified it here. So we got our LED. We initially test it with the speaker. So that comes on. Slide switch is just a little weak, but our LED lights up, so that means our LED is good. So let's take the speaker out, use our 100 ohm resistor, flip the switch, and the LED still lights. So that lets us know that the LED and this 100 ohm resistor are good. The next item it has us testing in the manual is our alarm IC. So for testing our alarm IC, it has us build project 17, and we start with it with a snap here. Then we're going to add another snap here, and then we're going to move that snap from here to there. So we're testing 3 different sounds out of our alarm IC to make sure our alarm IC is working. So this first one here should be a siren. And that one tests fine, so we're going to add a snap across here. And we should get a different sound, or at least a second one. The fact that we're not getting a second sound there and taking this on and off kind of tells me that there's a connection problem with the IC, either inside or the IC is damaged. So it's not working on that part. Move it over here. And that's working fine. That's a laser gun sound. So we got 2 of the 3 sounds, but we didn't get the one with the snap over here. We'll try something just for the sake of it. I don't know if you guys that have alarm ICs can tell me if that's the way that's supposed to sound, but it sounds really distorted. So that kind of tells me that this alarm IC might have a defective connection here inside it on this point, or we've got a bad integrated circuit in there. So this alarm IC is a little questionable. So next we're going to look at our music IC. So we're testing our music IC. It has us build project 74, but we substitute the photoresistor for the press switch because we're not testing the photoresistor just yet. So if I turn this circuit on, our red LED should flicker for a while and then go out, which is what it did. So the music IC is functioning correctly. If we press and hold down the press switch, our LED should come back on and flicker and continue doing that as long as I'm holding the button down. So the music IC should keep repeating. The moment I release the button, the IC should stop. And then, to test the replay, we just take a 3-snap and touch it here, and the music IC starts over again. And then stops. And of course this is our hold, and that works. So our music IC is good. So now we're going to move on to looking at our Space War IC and our photoresistor. So here we have our Space War IC set up, and it should have us put the sounds on when we use the push switch and our slide switch, and they should change as we turn those switches on and off. And that one works. So those work. Now I'm going to take our slide switch away, replace it with our photoresistor. So our Space War IC tests good, and our photoresistor tests good because the sounds were changing every time I was covering our photoresistor. So the last one in this manual that we're going to test is our whistle chip. So to test out our whistle chip, it has us build project 61, and we're going to vary the output audio, or I should say the amplitude on the whistle chip, with our photoresistor. So if it's covered up, it should get nice and quiet. If I shine a light on it, it should get louder. Right now it should be about medium or so. And I don't know how well the camera can hear that. So I'll bring it up to the camera here to hear. I'm going to cover up the photoresistor. It gets quieter. I take my hand away. Sound comes up. Now let me put a light on there. And now it gets louder. Take it away, it gets quieter. So our whistle chip is good, and again our photoresistor is working good too, controlling the volume. So that does it for troubleshooting the SC100. We're going to move up to the SC300 set now. And in that one, it's going to have us test both battery holders, which we kind of did, but we're going to test the 6-volt lamp with it and our second LED. So let me get that set up. So here we're going to test our 6-volt lamp and our green LED. It has us also testing the second battery holder and more of the snap wires, because you get more of them in the SC300 set, but we already did that at the beginning. So I am going to use this little jumper wire to test our 6-volt lamp. Our 6-volt lamp lights up nice and bright because our batteries are in series, giving us 6 volts, and that is a 6-volt lamp. So 6-volt lamp tests good. Let me switch over to our green LED. And our green LED lights up just fine, so that is working as well. So our next troubleshooting is going to be looking at the resistors, our 1000 ohm resistor, our 5100 ohm resistor, and our 10,000 ohm resistor. do that. So for having us test the 1000, 5100, and 10,000 ohm resistors, it has us build project 7 again. Again, just simplified it. We're using our red LED as a visual aid or switch, and then we got our 5.1 on there already. So actually, let me start with how it's supposed to be. Here's our 1000 ohm resistor. Turn our slide switch. Our LED comes on. Oops, accidentally pulled the whole assembly apart there. So our LED comes on, our 1000 ohm resistor is good. Let's move on to the 5100. Our LED should still light, but it should be less bright this time. And it is. Let me see if I'll bring it up for you to see. Our LED lights up, but it's dim. And then we go to our 10,000 ohm. And it lights, but it's just barely visible with so much resistance. I don't know how the camera's going to pick that up. Oh yeah, the camera picks it up. So that proves that our 5100, 1000, and 10,000 ohm resistors are good. So our next troubleshooting item is the antenna. So let's build that circuit. So for testing the antenna, it has us make an alarm circuit sound using the whistle chip and the antenna there to make a connection so that the whistle chip works. So if I turn this on, we hear sound. And if the antenna is missing or broken, we don't get any sound. So that proves that our antenna is intact and working. So now we're going to look at the NPN and our PNP transistors. So testing our NPN transistor here, we just built a little circuit with our red LED, resistance for that, and then resistance for our gate on our transistor. Press our press switch. Our LED lights up, so we know that our transistor is good. It's not burned out or damaged in any way. Now I'm going to switch. Well, what do you know? I just found my single snap. It was under the PNP transistor like that. So now I know where that one disappeared to. So now I'm going to reconfigure this for the PNP. So let me take this apart right quick. Pull that off. Pull this off. There, that there. And then let's see, R4 goes there. Now we have our circuit set up for the PNP because the PNP gate is controlled from a ground reference versus the positive reference with NPN. Press our button, our LED lights up. So that proves that our PNP and the NPN transistors are good. So our next testing item is going to be the adjustable or variable resistor. So for testing the variable resistor, it has us build project 261, and a fun fact is we actually haven't got this far in the Snap Circuits videos that I've done, because I think they stopped at 175. So we've got at least just under 100 projects to go still before we even get to this point. But for 261, it has us replace the photoresistor that would be here with the 100 ohm resistor. And when we turn on the circuit, we use our variable resistor, and that should turn on our LED. And if we do it just gradually, we can also adjust its brightness. So that lets us know that the resistor itself is working, it's just not shunting power to one side completely or the other. So we know that our variable resistor is working. So the next one we're going to be looking at is going to deal with capacitors. So we're going to look at our 100,000 ohm resistor along with our 0.02 microfarad, 0.1 microfarad, and 10 microfarad capacitors. So we're going to look at that now. So for testing our 100,000 ohm resistor and our 3 capacitors, our 0.02 microfarad, 0.1 microfarad, and 10 microfarad capacitors, we build project 206, which is the tone generator. And the first thing is that it should make a tone, and if it doesn't, we'll know that the resistor is bad. So it's generating a nice constant tone, so we know that the resistor is good. Now we're going to put our 0.02 microfarad capacitor over the whistle chip, and we should hear the pitch go down. And it does, so it's got capacitance across there. We take our 0.1 microfarad capacitor, and now the tone should be even lower. And it is. And then with our 10 microfarad capacitor, the charging of this should make the whistle chip just click about every second or two. And it does. So our capacitors are good, and so is our 100,000 ohm resistor. So our next troubleshooting item is going to be using our 100 microfarad capacitor and 470 microfarad capacitor. So we're going to test our bigger ones. So for testing the 100 microfarad and 470 microfarad capacitors, it has us build project 225. And with the 470 microfarad capacitor here, when we turn this circuit on, her LED should light up and then slowly get dimmer and dimmer until it goes completely out over the course of about 10 to 15 seconds or so. And you see the LED came on, got dimmer and dimmer, now it's completely out. And if we turn the circuit off and back on, you'll notice the LED does not come back on because our capacitor is all charged up, and so it's not allowing that transistor to turn on. And if we discharge the capacitor, then our LED can come back on. And as the capacitor charges back up, the LED loses more and more luminescence until it goes completely out. Discharge that. Now we take our 470 off, and we put our smaller 100 microfarad on. And this time, the light should go out in just a few seconds. See? So that proves that that our capacitor is working and that the values are right with the 470, because the 470 is a larger capacitor and can store more charge than this 100 microfarad, which is again why the light goes out sooner. So that proves that our 470 and 100 microfarad capacitors are okay. So our next troubleshooting item is going to be using our power amplifier IC. That's going to help us build project 293. So by building project 293, we make use of our power amplifier connected to our alarm IC, so that we can increase the power going to our speaker of the police siren that the alarm IC generates, and should make it louder. And the fact that we're getting sound there in it is audibly louder than the previous test we've done without the power amplifier shows that the power amplifier IC is working fine. So our next thing we get to try out is our microphone. So we built project 109, which is blowing off the electric light, and we use the microphone because when we blow on the microphone, it induces a current to charge up the capacitor, which then diverts current away from our lamp, allowing the light to go out. And it works. So, light goes out, of course it comes back on, but that proves that the microphone is working and the circuit is functional. now our next troubleshooting thing is going to have us looking at our variable capacitor. So for testing the high frequency IC, what it has us do is basically build the AM radio circuit. And we're going to use our variable capacitor to tune the frequency that it's picking it up on, and our variable resistor here is used for the power control on the power amplifier for the sound volume on the speaker. Let me turn this on. I got that max volume. I've had to try to turn some things off that were producing electrical noise so we could try to pick up an AM radio station here. Had something there. The problem is I've got an electrical cord right here too, nearby. Something right here. Okay, you might be able to hear the voice there. So I was basically using my hand there to kind of directionalize the antenna here to pick up the AM radio signals. So that shows that our high frequency IC is working, including our variable capacitor, because we weren't able to show that before, but like I said, I showed a previous project where you could test that itself. So that concludes the SC300's troubleshooting. Now we're going to step up to the SC500's book and do troubleshooting for the components in that set. So when we step up to the SC500 set, again it goes back to steps 1 through 20 of the troubleshooting, which we've already done to this point. So now we're going to build project 307, and we're going to test out the FM radio module. So with project 306, we build our adjustable volume FM radio. So we got our FM receiver module on there, along with our power amplifier and controls for the volume on that. So we turn the circuit on. And then we just find an available radio station with tuning it. There's one there. Oops. So it does work, but I had to cut the sound off there in the video because YouTube. So we know that the FM radio module here works fine. So our next thing we're going to troubleshoot is now going to be our current meter. So let's build that circuit. So for testing our current meter, it's a pretty simple circuit we build. We set it to the low scale, and we use our 10,000 ohm R4 resistor there. We turn it on. Our meter should almost go full scale deflection, showing about 9 to 10 milliamps of current there going through our resistor on the battery pack. And then switch it to its high scale, take this out, and then we replace that with our 2.5 volt lamp. Turn on the circuit. And now it's showing a bit more current, so we've got our high scale on there. So it shows that based on our switches, as you can see from the change on the light there, our meter is working just fine. So our meter is good. So now we're going to look at the recording IC. So if we were testing the recording IC, we build this circuit here, and our slide switch will tell the recorder to start recording for 8 seconds, and then our push button will allow us to listen to it and play back one of the 3 built-in songs on the recording IC. And again, we use our microphone, our speaker to hear it, And an interesting thing is it's using the D3 standard diode, which we actually haven't tested yet in the troubleshooting manual. It actually comes later, but I guess this is one way to tell if it works or not. So let's get something recorded here. Subscribe now. And then I'll save that recording, and then we'll press the button and should hear that back from the speaker along with a sound. Now, I was a little far away from the microphone, but it did pick me up on there. Bring this up here. Subscribe now. That's the second of the songs. Let's do it again. Subscribe now. So that proves that our recording IC is working both for taking in audio and playing it back, and playing back the 3 embedded songs already on the IC's flash memory. So the next item we're going to look at here for testing is our relay. So we're going to build that simple circuit and test the relay. So for testing our relay, the circuit is pretty simple there. We just have 2 LEDs. And the way it is, the green LED should be on when the relay is off. When the relay gets energized, our red LED should come on. Back off, it's green, red, green, red, green. And we can see the electromagnet in there pulling the plate in. So all our contacts are good. So we know that our relay is working just fine. So the next on our list to check is the transformer. So testing our transformer here is pretty simple in this circuit. Just use our 6-volt lamp, push button, our transformer, and our red LED with our 100 ohm resistor and a jumper wire. And when we press the button, we should see the LED flash as we energize and de-energize the transformer, because we're inducing a current on this side every time it gets energized, and then the field collapses. Flashes, flashes. So it works there. Move it to the other point here on the transformer. And it flashes there too. So our transformer tests good. So now we get to check that D3 diode, which, as I told you, we actually used in the recording IC circuit. So we should know that it's already good. So let's do it anyway. So testing our D3 diode, got our circuit together pretty simple there. As you see, our LED is dimly lit there because we're using a 1000 ohm resistor. We take our diode out, turn it around. The LED does not light up. Put it back the right way, and it does light up. So that tells us that our diode hasn't failed closed or failed open in any way. So our D3 standard diode works just fine. So the next item we're going to try out is our silicon control rectifier, or SCR. So for testing our silicon controlled rectifier, we just put our SCR in here with a 100 ohm with a press switch controlling the gate, and then a slide switch to control the power on and off with our motor as the controlled output. So turn it on. The motor doesn't spin, so our SCR is not stuck closed in any way. Press the press switch. The motor starts spinning, and it stays spinning regardless how many times we press the press switch. We turn power off, turn the power back on, and the motor does not start up again until we trip the SCR. So that proves that our silicon controlled rectifier is working fine. Again, not failed closed or open or any way. So the last thing in the SC500 we're going to test is our 7-segment LED display. Now for testing the 7-segment LED display, what I decided to do, instead of building the circuit they had where it just turns all the LEDs on the display on, I've just simplified it by connecting our 1000 ohm resistor to the input positive with the battery, and then using a jumper wire to go around each individual segment and test the display that way. So we'll test B, that lights, G lights, C lights, the dot point, that lights, D lights, E lights, just because I was holding it there, F lights, A lights. So our 7-segment LED display is working just fine. And so now that concludes the ST500's troubleshooting. Now we're going to go on to the last one, which is the ST750's troubleshooting. So doing the troubleshooting for the ST750, not a whole lot left to do. First one here is testing our solar cell with our meter, which I've already got set up there. And if you can see from the meter, it's already getting about 5 milliamps of current there just from the native light entering the solar cell. If I cover it up, it deflects all the way down. If I put a light on it, it deflects all the way over. So that concludes that our solar cell works. So now let's look at our electromagnet. So I got our electromagnet here. The circuit's pretty simple. We just got a 2.5 volt lamp. And it may be really hard to see on the camera. I don't know if I can justify that, but you might just see that the lamp is just turned on there. And then of course it gets brighter when you press the press switch. And that's because our electromagnet is a big coil of wire. It's basically just a big inductive coil there, so it's got quite a drop across it. But the fact that at least we have the lamp just turning on there lets us know that there's no broken connections or anything like that in our electromagnet. So that should be working properly. So one of the last things we're going to look at here is our vibration switch. So for this file, we've got our vibration switch in there with our red LED. Now I changed this to the 100 ohm resistor instead of the 1000 to make this a little more visible for you on camera. But the way this vibration switch is that when I hit or shake this board, you should see the LED light, and I'm hoping the camera will see it here. I can see the LED flashing every time I hit it. I hope the camera is picking this up. So that proves that our vibration switch works. And aside from our little custom attachment here, I really can't show the test for that because it's just dependent on whatever component you put across that. So that's pretty much it for the snap circuits troubleshooting. Now I know there is the computer interface section, but that's kind of a whole troubleshooting thing on its own because everyone's computers are different, and their sound card and their microphone setups and the volume on it and their connections, etc., etc. So there's a lot on that on its own. So that pretty much concludes the snap circuits troubleshooting, and you should start seeing some more projects coming up on the channel here pretty shortly. Subscribe now.